Artificial. INTELLIGANCE. Skill Enhance course. As per National Education Policy 2020. 1. Preface. At least since the 1st century BCE, humans have been intrigued by the possibility of creating machines that mimic the human brain. In modern times, the term artificial intelligence was coined in 1955 by John McCarthy. In 1956, McCarthy and others organized a conference titled the Dartmouth Summer Research Project on Artificial Intelligence. This beginning led to the creation of machine learning, deep learning, predictive analytics, and now to prescriptive analytics. It also gave rise to a whole new field of study, data science. Today, the amount of data that is generated, by both humans and machines, far outpaces humans' ability to absorb, interpret, and make complex decisions based on that data. Artificial intelligence forms the basis for all computer learning and is the future of all complex decision-making. As an example, most humans can figure out how to not lose at tic-tac-toe, noughts and crosses, even though there are 255,168 unique moves, of which 46,080 end in a draw. Far fewer folks would be considered grand champions of checkers, with more than 500 x 1018, or 500 quintillion, different potential moves. Computers are extremely efficient at calculating these combinations and permutations to arrive at the best decision. AL, and its logical evolution of machine learning and deep learning are the foundational. Finally, we profusely thank branch managers of Kalyani Publishers Mr. Muhammad Samir for coming forward to publish our work. We will accept the comments and suggestion from our readers to improve the contents. Professor Reshma B. Professor AKSHATHAMR. Professor AMABRISHR. Professor DADAVALISP. 3. Acknowledgement. We are thankful to a large number of intellectual individuals who have encouraged us in authoring this book. We would like to express our deep sense of gratitude to authors and scholars in the field of management who have shaped us in understanding through their rich and valuable contributions, and also to our students' fraternity for providing us the stimulus needed for shaping this book in a useful manner. In particular, we wish to thank profusely Dr. Ramachandra Gowda, Vice-Chancellor, Rani Chennamma University, Dr. R. Chenraj Jain, Chairman Jain Group of Institutions, Dr. N. Sundararajan, Vice-Chancellor, Jain University, Professor V. H. Rajshekhar, Principal, GFGC Ramanagara Drive, B. T. Venkatesh, Principal, Jain University, Dr. B. Anuradha, Principal, Al-Amin Institute of Management Studies, Bangalore, Mr. Ravikumar S. of Eshel Cybervilla, Kangari, Bangalore, for their invaluable encouragement, guidance and contributions in shaping this book. Finally, we express our deep sense of gratitude of our family members for their wholehearted support in authoring this book in a useful manner. Professor AKSHATHAMR. Professor Reshma B. Professor AMABRISHR. Professor DADAVALISP. 4. Syllabus. Course content: Artificial Intelligence. Details of topic. Duration. Course 1, Azure AI Fundamentals, AI 900. AI 900 pathway consists of 5 courses and 2.05 hours. Reading material. I. Introduction to AL on Azure. E. Use visual tools to create machine learning models with Azure Machine Learning. E. Explore computer vision in Microsoft Azure. IV. Explore natural language processing versus explore conversational AI. V. Tune model hyperparameters, Azure. Machine learning. Reading. V. Neural network regression, module. Reference Azure Machine Learning. 2. Describe fundamental principles of machine learning on Azure. 3. Describe features of computer vision workloads on Azure. 4. Describe features of natural language processing, NLP, workloads on Azure. Course outcomes, COUS. Appraise the theory of artificial intelligence and list the significance of AL. Discuss the various components that are involved in solving an AI problem. Black circle illustrate the working of AI algorithms in the given contrast. Analyze the various knowledge representation schemes, reasoning and learning techniques of AID. Apply the AL concepts to build an expert system to solve the real world problems. Course 1. Azure I Fundamentals, AI 900. 1.1 Introduction. AL is touching us in all aspects of our daily lives, most of the times unknowingly. Whenever we shop online, use our mobiles, drive to work daily, check our mailbox or exercise, AL is coming into play and helping us, prodding us or controlling us. Since AI is already such an integral part of our lives, it makes sense to get more knowledge of this emerging technology. From chess-playing computers to self-driving vehicles, artificial intelligence, AI, is progressing rapidly and touching every aspect of our lives. In this module, you will learn how machines can be made to learn from data and carry out human tasks. AI enables us to build amazing software that can improve healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. 1.2 What is artificial intelligence? Artificial intelligence is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. Simply put, AI is the creation of software that imitates human behaviors and capabilities. 1.2.1 Artificial Intelligence Definition, Basics of AI. AI is intelligence demonstrated by machines, as opposed to the natural intelligence displayed by humans or animals. Key workloads include machine learning. This is often the foundation for an AI system, and is the way we teach a computer model to make prediction and draw conclusions from data. Anomaly detection. The capability to automatically detect errors or unusual activity in a system. Computer vision. The capability of software to interpret the world visually through cameras, video, and images. Natural language processing. The capability for a computer to interpret written or spoken language and respond in kind. Knowledge mining. The capability to extract information from large volumes of often unstructured data to create a searchable knowledge store. Business intelligence. Artificial intelligence. Machine learning. Natural language processing. Big data. Deep learning. Question answering. Data. Predictive analytics. Cognitive computing. Statistics. 8. 1.3 Use visual tools to create machine learning models with Azure Machine Learning. The phrase, "every model is wrong, but some are useful," is especially true in machine learning. When developing machine learning models, you should always understand where it works as expected and where it fails miserably. An important method of understanding a model is through model visualization. Visualizing the model architecture is important for model explainability, black circle results interpretation, black circle model debugging, model comparison. Once you get some decent understanding of one model, you are good, right? No, it is wrong. Typically, you need to do some or a lot of experimenting with model improvement ideas, and visualizing differences between various ML experiments becomes crucial. There are many methods that you can use to get that understanding. Look at evaluation metrics. Also, you should know how to choose an evaluation metric for your problem. Black circle look at performance charts like ROC, lift curve, confusion matrix, and others. Look at learning curves to estimate overfitting. Black circle look at model predictions on best-worst cases. Look how resource-intensive is model training and inference. They translate to serious costs and will be crucial to the business side of things. Use model interpretation tools and techniques to vet predictions. 9. 1.3.1 Tools for Machine Learning Experiments Visualization. 1. Neptune. Neptune is a metadata store for MLOps, built for teams that run a lot of experiments. It gives you a single place to log, store, display, organize, compare, and query all your model building metadata. Neptune is used for experiment tracking. Log, display, organize, and compare ML experiments in a single place. Black Circle Model Registry. Version, store, manage, and query trained models. And model building metadata. Monitoring ML runs live. Record and monitor model training, evaluation, or production runs live. How can Neptune help you visualize experiments and models? Log any metadata type, including parameters and metrics, but also rich objects like images, video, audio, and interactive visualizations. Visualize logged metadata and analyze results in a preferred way, in the runs table, as charts, in dashboards, or in a folder structure. Compare hyperparameters and metrics across many runs within intelligent compare table that highlights what was different. Black circles see how different parameters and configs affect the results, and debug and optimize models. Automatically monitor hardware utilization, GPU, CPU, memory. Register models and metadata associated with them. 2. Weights and Biases. Weights and Biases is a machine learning platform for developers to build better models faster. It lets you quickly track experiments, version and iterate on datasets, evaluate model performance, reproduce models, visualize results and spot regressions, and share findings with colleagues. How can weights and biases help you visualize experiments and models? 10. Monitor training runs information like loss, accuracy, learning curves, view histograms of weights and biases, no pun intended, or gradients. Log rich objects like charts, video, audio, or interactive charts during training. Use various comparison tools like tables showing autodiffs, parallel Coordinates plot and others. Interactive prediction bounding box visualization for object detection. Models black circle interactive prediction masks visualization for semantic segmentation. Models. Black circle visualize live metrics like GPU and CPU utilization. Build dataset dependency graphs. Visualize parameter importance. 3. Comet. Comet is an ML platform that helps data scientists track, compare, explain and optimize experiments and models across the model's entire lifecycle, i.e. from training to production. In terms of experiment tracking, data scientists can register datasets, code changes, experimentation history, and models. Comet is available for teams, individuals, academics, organizations, and anyone who wants to easily visualize experiments, facilitate work, and run experiments. It can be used as a hosted platform or deployed on-premise. Main advantages. Fully customizable experiment table within the web-based user interface. Extensive comparison features code, hyperparameters, metrics, predictions, dependencies, system metrics, and more. Dedicated modules for vision, audio, text, and tabular data that allow for easy identification of issues with the dataset. Sacred Omniboard. Sacred is open-source software that allows machine learning researchers to configure, organize, log, and reproduce experiments. Sacred does not come with its proper UI, but there are a few dashboarding tools that you can connect to it, such as Omniboard, but you can also use others, such as Sacred Board or Neptune via integration. Sacred doesn't have the scalability of the previous tools and has not been adapted to team collaboration, unless integrated with another tool. However, it has great potential when it comes to individual research. Main advantages. Possibility to connect it to the preferred UI. Possibility to track any model training developed with any Python. Library. Extensive experiment parameters customization options. 5. MLflow. MLflow is an open-source platform that helps manage the whole machine learning lifecycle. This includes experimentation, but also model storage, reproducibility, and deployment. Each of these 4 elements is represented by one MLflow component: tracking, model registry, projects, and models. The MLflow tracking component consists of an API and UI that support logging various metadata, including parameters, code versions, metrics, and output files, and later visualizing the results. Main advantages. Black Circle focus on the whole lifecycle of the machine learning process. Strong and big community of users that provide community support. Open interface that can be integrated with any ML library or language. F12. 1.4 Explore computer vision. Computer vision is a field of artificial intelligence, AI, that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs and take actions or make recommendations based on that information. If AI enables computers to think, computer vision enables them to see, observe, and understand. Computer vision works much the same as human vision, except humans have a head start. Human sight has the advantage of lifetimes of context to train how to tell objects apart, how far away they are, whether they are moving, and whether there is something wrong in an image. Computer vision trains machines to perform these functions, but it must do it in much less time with cameras, data and algorithms rather than retinas, optic nerves and a visual cortex. Because a system trained to inspect products or watch a production asset can analyze thousands of products or processes a minute, noticing imperceptible defects or issues, it can quickly surpass human capabilities. Computer vision is used in industries ranging from energy and utilities to manufacturing and automotive, and the market is continuing to grow. It is expected to reach $48.6 billion United States dollars by 2022. 1.4.1 How does computer vision work? Computer vision is an area of artificial intelligence, AI, in which software systems are designed to perceive the world visually, through cameras, images, and video. There are multiple specific types of computer vision problem that AI engineers and data scientists can solve using a mix of custom machine learning models and platform as a service (PaaS) solutions, including many cognitive services in Microsoft Azure. Computer vision is one of the core areas of artificial intelligence, AI, and focuses on creating solutions that enable AI applications to see the world and make sense of it. 13. Of course, computers don't have biological eyes that work the way ours do, but they are capable of processing images, either from a live camera feed or from digital photographs or videos. This ability to process images is the key to creating software that can emulate human visual perception. Some potential uses for computer vision include content organization. Identify people or objects in photos and organize them based on that identification. Photo recognition applications like this are commonly used in photo storage and social media applications. Text extraction. Analyze images and PDF documents that contain text and extract the text into a structured format. Black circle spatial analysis. Identify people or objects, such as cars, in a space and map their movement within that space. To an AI application, an image is just an array of pixel values. These numeric values can be used as features to train machine learning models that make predictions about the image and its contents. Training machine learning models from scratch can be very time-intensive and require a large amount of data. Microsoft's computer vision service gives 14. Access to pre-trained computer vision capabilities. Taxi. Computer vision models and capabilities. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. The following table describes common computer vision tasks. Filled square image classification. Image classification involves training a machine learning model to classify images based on their contents. For example, in traffic monitoring solution you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. Object detection. Object detection machine learning models are trained to classify individual objects within an image and identify their location with a bounding box. For example, a traffic monitoring solution might use object detection to identify the location of different classes of vehicle. Filled square semantic segmentation. Semantic segmentation is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, A traffic monitoring solution might overlay traffic images with mask layers to highlight different vehicles using specific colors. 15. Non-bank. The Toronto Dominion Bank. The Toronto DOWMON. A person with a dog on a street. Filled square image analysis. You can create solutions that combine machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarize the scene shown in the image. Bus. Bus. Cyclist. Cyclist. Bus car cyclist. Car. Face detection, analysis, and recognition. Face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classification and facial geometry analysis techniques to recognize individuals based on their facial features. Optical character recognition, OCR. Optical character recognition is a technique used to detect and read text in images. You can use OCR to read. 16. Text in photographs, for example, road signs or storefronts, or to extract information from scanned documents such as letters, invoices, or forms. 1.4.2 Explore natural language processing. Natural language processing supports applications that can see, hear, speak with, and understand users. Using text analytics, translation, and language understanding services, Microsoft Azure makes it easy to build applications that support natural language. Analyzing text is a process where you evaluate different aspects of a document or phrase in order to gain insights into the content of that text. For the most part, humans can read some text and understand the meaning behind it. Even without considering grammar rules for the language the text is written in, specific insights can be identified in the text. As an example, you might read some text and identify some key phrases that indicate the main talking points of the text. You might also recognize names of people or well-known landmarks such as the Eiffel Tower. Although difficult at times, you might also be able to get a sense for how the person was feeling when they wrote the text, also commonly known as sentiment. Text analytics techniques. Text analytics is a process where an artificial intelligence (AI) algorithm running on a computer evaluates these same attributes in text to determine specific insights. A person will typically rely on their own experiences and knowledge to achieve the insights. A computer must be provided with similar knowledge to be able to perform the task. There are some commonly used techniques that can be used to build software to analyze text, including 17. Statistical analysis of terms used in the text. For example, removing common, stop words like the, or, a, which reveal little semantic information about the text, and performing frequency analysis of the remaining words, counting how often each word appears, can provide clues about the main subject of the text. Extending frequency analysis to multi-term phrases, commonly known as n-grams. A two-word phrase is a bigram, a three-word phrase is a trigram, and so on. Applying stemming or lemmatization algorithms to normalize words before counting them, for example, so that words like power, powered, and powerful are interpreted as being the same word. Applying linguistic structure rules to analyze sentences, for example, breaking down sentences into tree-like structures such as a noun phrase, which itself contains nouns, verbs, adjectives, and so on. Black circle encoding words or terms as numeric features that can be used to train a machine learning model. For example, to classify a text document based on the terms it contains. This technique is often used to perform sentiment analysis, in which a document is classified as positive or negative. Creating vectorized models that capture semantic relationships between words by assigning them to locations in n-dimensional space. This modeling technique might, for example, assign values to the words flower and plant that locate them close to one another, while skateboard might be given a value that positions it much further away. While these techniques can be used to great effect, programming them can be complex. In Microsoft Azure, the Language Cognitive Service can help simplify application development by using pre-trained models that can black circle determine the language of a document or text, for example, French or English. Perform sentiment analysis on text to determine a positive or negative sentiment. 18. Extract key phrases from text that might indicate its main talking points. Identify and categorize entities in the text. Entities can be people, places, organizations, or even everyday items such as dates, times, quantities, and so on. 1.4.3 Explore conversational AI. Conversational AI is an umbrella term used to describe various methods of enabling computers to carry on a conversation with a human. This technology ranges from fairly simple natural language processing, NLP, to more sophisticated machine learning, ML, models that can interpret a much wider range of inputs and carry on more complex conversations. One of the most common applications of conversational AI is in chatbots, which use NLP to interpret user inputs and carry on a conversation. Other applications include virtual assistants, customer service chatbots, and voice assistants. Savvy consumers expect to communicate via mobile app, web, interactive voice response, IVR, chat, or messaging channels. They look for a consistent and enjoyable experience that's fast, easy, and personalized. For businesses, the key to meeting and exceeding these expectations across channels and at scale is intelligent automation. Conversational artificial intelligence, AI, powers interactions that are near human, improving CX, boosting satisfaction, driving loyalty, and increasing customer lifetime value, LTV. 1.4.4.1 Components of conversational AI. Conversational AI can be broken down into 5 core components. These 5 core components work together to enable a computer to understand and respond to human conversation. 1. Natural language processing. NLP is the ability of a computer to 19. Understand human language and respond in a way that is natural for humans. This involves understanding the meaning of words and the structure of sentences, as well as being able to handle idiomatic expressions and slang. NLP is made possible by machine learning, which is used to train computers to understand language. NLP algorithms use large datasets to learn how words are related to each other, and how they are used in different contexts. 2. Machine learning. Machine learning is a field of artificial intelligence that enables computers to learn from data without being explicitly programmed. Machine learning algorithms can automatically improve their performance as they are exposed to more data. Machine learning is used to train computers to understand language, as well as to recognize patterns in data. It is also used to create models of how different things work, including the human brain. 3. Text analysis. Text analysis is the process of extracting information from text data. This involves identifying the different parts of a sentence, such as the subject, verb, and object. It also includes identifying the different types of words in a sentence, such as nouns, verbs, and adjectives. Text analysis is used to understand the meaning of a sentence, as well as the relationships between different words. It is also used to identify the topic of a text, as well as the sentiment, positive or negative, of the text. 4. Computer vision. Computer vision is the ability of a computer to interpret and understand digital images. This involves identifying the different objects in an image, as well as the location and orientation of those objects. Computer vision is used to identify the contents of an image, as well as the relationships between different objects in the image. It is also used to interpret the emotions of people in photos, and to understand the context of a photo. 5. Speech recognition. Speech recognition is the ability of a computer to 20. Understand human speech. This involves recognizing the different sounds in a spoken sentence, as well as the grammar and syntax of the sentence. Speech recognition is used to convert spoken words into text, and to understand the meaning of the words. It is also used to interpret the emotions of people speaking in a video, and to understand the context of a conversation. 1.4.4.2 How does conversational AI work? Driven by underlying machine learning in deep neural networks, DNN, a typical conversational AI flow includes an interface that allows the user to input text into the system, or automatic speech recognition, ASR, a user interface that converts speech into text. Natural language processing, NLP, to extract the user's intent from the text or audio input, and translate the text into structured data. Natural language understanding, NLU, to process the data based on grammar, meaning, and context, to comprehend intent and entity, and to act as a dialogue management unit for building appropriate responses. An AI model that predicts the best response for the user based on the user's intent and the AI model's training data. Natural language generation, NLG, infers from the above processes, and forms an appropriate response to interact with humans. In many cases, the user interface, NLP, and AI model are all provided by the same provider, often a conversational AI platform provider. However, it is also possible to use different providers for each of these components. 21. Machine learning and deep neural networks. Automated speech recognition. Hi, I want to change my flight itinerary. Listening. Dialogue management. Natural language generation. Forming response. Natural language understanding. Offering response. Sure, I can help change your flight. Comprehending. 1.4.4.3 How to create conversational AI. There is no one-size-fits-all answer to this question, as the best way to create conversational AI depends on the specific needs and use cases of your organization. However, some tips on how to create conversational AI include: 1. Start by understanding your use cases and requirements. The first step in creating conversational AI understands your organization's specific needs and use cases. What are you trying to achieve with your chatbot? What type of conversations do you want it to be able to have? What data do you need to collect and track? Defining these requirements will help you determine the best approach to creating your chatbot. 2. Choose the right platform and toolkit. There are several different platforms and toolkits that you can use to create conversational AI. Each platform has its own strengths and weaknesses, so you need to choose the platform that best suits your needs. Some popular platforms include 24/7.ai Conversations, Microsoft Bot Framework, Amazon Lex, Google Dialogflow, and IBM Watson. 3. Build a prototype. Once you have defined your requirements and chosen a platform, it's time to start building your prototype. Building a prototype will help you test your chatbot and iron out any kinks before deploying it to your users. 4. Deploy and test your chatbot. Once your prototype is finished, it's time 22. To deploy and test your chatbot, make sure to test it with a small group of users first to get feedback and make any necessary adjustments. 5. Optimize and improve your chatbot. The final step is to continually optimize and improve your chatbot. You can do this by tweaking the algorithms, adding new features, and collecting user feedback. The NLP pipeline. Context model. Response. Chat client. Utterance. Chatbot. NLP NLU. Entity. Language detection. Intent prediction. Entity extraction. Intent prediction. Extraction. Conversational AI challenges. Conversational AI's maturity has steadily increased over the past few years to the point where it can now deliver excellent business value and outcomes for companies. Nevertheless, challenges abound since this is also a fast-evolving conversational commerce category where very few vendors are constantly innovating and bringing new technologies to the market. Challenges include developing natural language processing, NLP, capabilities that can understand and interpret human interactions. This is a complex task that requires significant effort and investment in research and development. Understanding the context of a conversation in order to provide accurate responses. This can be particularly challenging in conversations that involve multiple people or multiple topics. The need for sophisticated design and development efforts to create a customer experience that engages users and keeps them engaged in the conversation. Deploying and integrating a conversational AI solution into an existing business or application can be a significant challenge. Proper planning and execution are essential to ensure a successful deployment. Ensuring the security and privacy of data exchanged via multiple conversational AI-powered channels. This applies to any CX-related information exchange. Compliance with standards such as GDPR, CCCP, and other country-specific regulations is also critical. As conversational AI permeates global CX platforms, local language support becomes a high priority. Leading brands operating worldwide can't rely on availability in just one language to meet local needs at scale. Building a robust conversational AI platform to operate in regional languages, dialects, slang, noisy environments, with crosstalk, etc., is a huge challenge. Dialogue management and conversation design are non-trivial parts of conversational AI. Annotating the intelligence gathered from real agent conversations and building the right model training data requires ongoing human-in-the-loop expertise. Building a conversational AI-based application that takes into consideration intent, entity extraction, sentiment analysis, and empathy is challenging, and very few vendors offer solutions with these features. Explainable AI. Not all conversational AI platforms use this data science tool, which eliminates algorithmic black boxes and helps answer the why within the model's functionality. Explainable AI also improves trust in the platform's ability to produce accurate, fair, and transparent results. Keeping automated conversations relevant can also be a real challenge, with customer needs and preferences changing faster than ever before. As a result, you may need people with coding skills, multiple persona models, or IT input, making the solution more expensive. Conversational AI platforms that have no-code, low-code self-serve capabilities can enable business users to build and deploy voice and digital bots and context-aware conversational flows in just a few days. State-of-the-art conversational AI. Technology behind conversational bot experiences is based on the latest advances in artificial intelligence, NLP, sentiment analysis, deep learning, and intent prediction. Together, these features encourage engagement, improve customer experience and agent satisfaction, accelerate time to resolution, and grow business value. Natural language processing, NLP. Most conversational AI uses NLU to intelligently process user inputs against multiple models, enabling a bot to respond in a more human-like way to non-transactional journeys. The core technology understands slang, local nuances, colloquial speech, and can be trained to emulate different tones by using AI-powered speech synthesis. Sentiment analysis. This leading conversational AI technology layer abstracts pre-built sentiment and social models to prioritize and seamlessly escalate to an agent when it detects that a customer needs expert advice. Sentiment detection will recognize, for example, an upset customer and immediately route them to an agent. You can also prioritize unhappy customers in the system, placing them in special queues or offering exceptional services. Deep learning. This machine learning technique is inspired by the human brain or neural network and allows AI to learn by association, just like a child. The more data AI is exposed to, the better it gets and the more accurately it can respond over time. AI models trained with many years of contact center data from various voice and digital channels result in smarter and more accurate responses to human inquiries. Response accuracy can be further improved over time by learning from interactions between customers, chatbots, and human agents, and optimizing intent models using AI-powered speech synthesis. Intent prediction. Using behavioral analysis and tagging activities, conversational AI technologies can understand the true meaning behind each consumer's 26. Request. Knowing intent allows companies to deliver the right response at the right moment through an automated bot or human agent. The future roadmap for conversational AI platforms includes support for multiple use cases, multi-domain, and multiple vertical needs, along with explainable AI. The conversational AI vendor market. According to Gartner, over 1,500 conversational AI providers now offer various levels of capability, language support, use cases, and business models. Sophistication swings widely depending on what's supported, such as number of integrations with back-end systems such as CRM, number and type of channels, voice, text-based chatbots, messaging, etc. Customization of chatbots and virtual assistants for vertical-specific use cases and applications for faster adoption into production. Number of languages, slang, dialects, local lingo, shorthand, phonetic spelling, grammatical structures, intents, entity, etc. Horizontal solutions are the most flexible and controllable but take longer to implement, while vertical-specific ones come with pre-built capabilities that are a better fit for a specialized use cases in a target domain. Vendors that offer vertical solutions built on an established horizontal platform give companies full flexibility in customizing to meet their precise needs. How to pick the right conversational AI solution. When it comes to selecting a conversational AI solution, there are a few key factors to consider. 27. 1. First, consider the needs of your business. What questions or tasks do your customers commonly ask or need help with? What areas of your business could benefit from automation? 2. Next, evaluate the capabilities of different conversational AI solutions. Some platforms are better suited for specific tasks or industries, while others are more versatile. 3. Finally, consider the cost and complexity of implementing different solutions. Some platforms are more expensive or require more technical expertise to set up and use. Once you have a better understanding of your business needs and the capabilities of different conversational AI solutions, you can begin to narrow down your options and select the right platform for your business. 1.5 Tune Model Hyperparameters, Azure Machine Learning. Here we will see how to use the Tune Model Hyperparameters component in Azure Machine Learning Designer. The goal is to determine the optimum hyperparameters for a machine learning model. The component builds and tests multiple models by using different combinations of settings. It compares metrics over all models to get the combinations of settings. The terms parameter and hyperparameter can be confusing. The model's parameters are what you set in the right pane of the component. Basically, this component performs a parameter sweep over the specified parameter settings. It learns an optimal set of hyperparameters, which might be different for each specific decision tree, dataset, or regression method. The process of finding the optimal configuration is sometimes called tuning. The component supports the following method for finding the optimum settings for a model: integrated train and tune. In this method, you configure a set of parameters to use. You then let the component iterate over multiple combinations. The component measures accuracy until it finds a best model. With most learner components, you can choose which parameters 28 should be changed during the training process, and which should remain fixed. Depending on how long you want the tuning process to run, you might decide to exhaustively test all combinations. Or you might shorten the process by establishing a grid of parameter combinations and testing a randomized subset of the parameter grid. How to configure tune model hyperparameters. Learning the optimal hyperparameters for a machine learning model requires considerable use of pipelines. Train a model by using a parameter sweep. This section describes how to perform a basic parameter sweep, which trains a model by using the tune model hyperparameters component. 1. Add the tune model hyperparameters component to your pipeline in the designer. 2. Connect an untrained model to the leftmost input. 3. Add the dataset that you want to use for training, and connect it to the middle input of tune model hyperparameters. Optionally, if you have a tagged dataset, you can connect it to the rightmost input port, optional validation dataset. This lets you measure accuracy while training and tuning. 4. In the right panel of Tune Model Hyperparameters, choose a value for parameter sweeping mode. This option controls how the parameters are selected. Entire grid. When you select this option, the component loops over a grid predefined by the system, to try different combinations and identify the best learner. This option is useful when you don't know what the best parameter settings might be and want to try all possible combinations of values. Random sweep. When you select this option, the component will randomly select parameter values over a system-defined range. You must specify the maximum number of runs that you want the component to execute. This option is useful when you want to increase model performance by using the metrics of your choice but still conserve computing resources. 5. For label column, open the column selector to choose a single label column. 6. Choose the number of runs. Maximum number of runs on random sweep. If you choose a random sweep, you can specify how many times the model should be trained by using a random combination of parameter values. 7. For ranking, choose a single metric to use for ranking the models. When you run a parameter sweep, the component calculates all applicable metrics for the model type and returns them in the sweep results report. The component uses separate metrics for regression and classification models. However, the metric that you choose determines how the models are ranked. Only the top model, as ranked by the chosen metric, is output as a trained model to use for scoring. 8. For random seed, enter an integer number as a pseudo-random number generator state used for randomly selecting parameter values over a predefined range. This parameter is only effective if parameter sweeping mode is random sweep. 9. Submit the pipeline. Results of hyperparameter tuning. When training is complete, black circle to view the sweep results. You could either right-click the component, and then select Visualize, or right-click left output port of the component to visualize. The sweep results includes all parameter sweep and accuracy metrics that apply to the model type, and the metric that you selected for ranking determines which model is considered best. To save a snapshot of the trained model, select the Outputs plus Logs tab in the right panel of the Train Model component. Select the Register Dataset icon to save the model as a reusable component. Train a model by using a parameter sweep. This section describes how to perform a basic parameter sweep, which trains a model by using the Tune Model Hyperparameters component. 1. Add the Tune Model Hyperparameters component to your pipeline in the designer. 2. Connect an untrained model to the leftmost input. Neural network regression. Let us discuss about a component in Azure Machine Learning Designer. This component is used to create regression model using a customizable neural network algorithm. Although neural networks are widely known for use in deep learning and modeling complex problems such as image recognition, they are easily adapted to regression problems. Any class of statistical models can be termed a neural network if they use adaptive weights and can approximate nonlinear. 31. Functions of their inputs. Thus, neural network regression is suited to problems where a more traditional regression model cannot fit a solution. Neural network regression is a supervised learning method, and therefore requires a tagged dataset, which includes a label column. Because a regression model predicts a numerical value, the label column must be a numerical data type. The model can be trained by providing a model and the tagged dataset as an input to train the model. The trained model can then be used to predict values for the new input examples. Configure neural network regression. Create a neural network model using the default architecture. If you accept the default neural network architecture, use the Properties pane to set parameters that control the behavior of the neural network, such as the number of nodes in the hidden layer, learning rate, and normalization. Start here if you are new to neural networks. The component supports many customizations, as well as model tuning, without deep knowledge of neural networks. Black circle define a custom architecture for a neural network. Use this option if you want to add extra hidden layers, or fully customize the network architecture, its connections and activation functions. This option is best if you are already somewhat familiar with neural networks. You use the NetHash language to define the network architecture. 1. Create a neural network model using the default architecture. Add the neural network regression component to your pipeline in the designer. You can find this component under Machine Learning, Initialize in the Regression category. Indicate how you want the model to be trained by setting the Create Trainer Mode option. Single parameter. Choose this option if you already know how you want to configure the model. Parameter range. Select this option if you are not sure of the best. Parameters, and want to run a parameter sweep. Select a range of values to iterate over, and the tuned model hyperparameters iterates over all possible combinations of the settings you provided to determine the hyperparameters that produce the optimal results. Black circle in hidden layer specification. Select fully connected case. This option creates a model using the default neural network architecture, which for a neural network regression model, has these attributes. The network has exactly one hidden layer. The output layer is fully connected to the hidden layer and the hidden layer is fully connected to the input layer. Idiographic period. The number of nodes in the hidden layer can be set by the user. Default value is 100. Because the number of nodes in the input layer is determined by the number of features in the training data in a regression model, there can be only one node in the output layer. For number of hidden nodes, type the number of hidden nodes. The default is one hidden layer with 100 nodes. This option is not available if you define a custom architecture using NetHash. For learning rate, type a value that defines the step taken at each iteration before correction. A larger value for learning rate can cause the model to converge faster, but it can overshoot local minima. Black circle for number of learning iterations. Specify the maximum number of times the algorithm processes the training cases. Black circle for the momentum. Type a value to apply during learning as a weight on nodes from previous iterations. Select the option, Shuffle Examples, to change the order of cases between iterations. If you deselect this option, cases are processed in exactly the same order each time you run the pipeline. Black circle for random number seed. You can optionally type a value to use as the seed. Specifying a seed value is useful when you want to ensure repeatability across runs of the same pipeline. Connect training data set and train the model. 33. If you set create trainer mode to single parameter, connect a tagged data set in the train model component. If you set create trainer mode to parameter range, connect a tagged data set and train the model by using tune model hyperparameters. Submit the pipeline. AdventureWorks Target Mall. Multi-class decision forest. TN. Select columns in dataset. Split data. Train model. Score model. Evaluate model.